Welcome everyone. We are discussing significance of derivative. Actually, we are discussing derivative as a rate of measure. So this is part 4. Part 4. So some problem of board as well as competitive exam. A man 2 meters high walks at a uniform speed of 6 meters per minute away from lamp post 5 meters high. Find the rate at which the length of the shadow increases. Length of the shadow increases. So man is walking on a road. We suppose that road is obviously horizontal. Lamp post, away from lamp post. AB is lamp post and it is 5 meters high. 5 meters high. So this is man, NN of height 2 meters, and he is walking away from lamp post. Away from lamp post. Now this is man and this is the lamp post, source of light. So we know the shadow of the man will be in opposite direction of the lamp and it will be on the road. So join BN. So join BN and extended BN meets the horizontal surface at O. So what is ANO? ANO is length of shadow. It will be on the road opposite to the lamp post. So let ANO is X and A, this is Y. This is Y. AM, distance of the man from lamp post. So this is Y. So dy by dt equals to a rate of change of Y, that is velocity of the man. And you have to find the rate of change of shadow, that is dx by dt. Dx by dt. So there is no direct relation given to x and y. So using properties of similar triangle, you have to find a relation between x and y. Now look, triangle now we have to find a relation between x and y from a relation of similar triangle. Now BAO, triangle BAO and triangle MNO are similar. So you know corresponding sides are proportional. Now opposite of O is common angle. So opposite of O, this is BA by MN. BA by MN. Now this angle equals to this angle. They are parallel. So opposite to B, that is AO. And this for this triangle, this is ANO. Now 5 by 2, what is AO? X plus y, and this is x. So 5x equals to 2x plus 2y. So we are getting 3x equals to 2y. So this is a relation between x and y. Now differentiating with respect to t. So 3 into dx by dt equals to 2 into 3y by dt. Now 2 unknown, dx dt and dy dt. One is given. So rate of speed of the man, that is here dy by dt equals to 6 meter per minute. So 3 into dx dt equals to 2 into 6. So dx by dt equals to 4. Dx by dt equals to 4. So look, 3 into dx dt. So 3 into dx dt unknown and 2 into dy dt is 6. So dx dt equals to 4. So dx dt, x is length of shadow, dx dt, rate of change of length of shadow, rate of change of shadow, rate of change of shadow equals to 4 meter per second. So 4 meter per minute. So it is in terms of minute. Now sometimes it is given that sometimes it is asked that how the tip of the shadow is changing. How the tip of the shadow is changing. Tip means farthest corner of the shadow. So farthest corner equals to O. So ddt of AO. ddt of what is AO? X plus y. ddt of change of tip of shadow. So this is dx plus dy by dt. So this is 6 and this is 4. dx dt 4 and dy dt is 6. So 10 meter per minute. 10 meter per minute. So you form a relation. Draw the figure and you form a relation between x and y and solve it. Next, this is most important problem for board. So problem number 2. A ladder 5 meter long leaning against a wall. So there are, we suppose that 2 walls, this one and this one. This is horizontal surface and this is wall. They are perpendicular. And AB is ladder. Now this is O, this is X, this is Y. A ladder 5 meter long. This is fixed. Leaning against a wall. This is wall. The bottom of the ladder is pulled along the ground. This is bottom of the ladder. It is pulled along the ground. So suppose this one is X and this one is Y. So you need to take meter. So if you pull it, so X increases, but Y decreases. But this one is always remaining fixed. At a rate of 2 meter per second. So dx dt equals to 2 meter. How fast the height of the wall is decreasing. So dy by dt you have to find. And ladder is 4 meter away from the wall. So let you formulate it. let OA equals to x meter and OB equals to y meter. So from figure, x square plus y square equals to 5 square. So call it 1. Now differentiate 2x dx dt, 2y dy dt with respect to t equals to 0. So x dx dt plus y dy dt equals to 0. So call it 2. Now look, out of 4 unknowns, 3 should be given. You look, the bottom of the ladder is pulled along the ground away from the wall at a rate of 2 meter per second. So here dx dt equals to 2 meter per second. How far the height of the wall decreasing, so dy by dt you have to find when ladder is 4 meter away from the wall. So x equals to 4 meter. So you get x and dx. You have to find dy by dt. So you have to know y. So y is not given directly, but from 1. What is y? Y square equals to 5 square minus x square. 5 square minus 4 square. So this is 9. So y equals to 3. So this is 3. So put the values in 2. So from 2, x, what is x? 4 into dx dt equals to 2. What is y? 3 into dy equals to 0. So dy dt equals to minus 8 by 3. So as x increases, y decreases. That is why dy dt is negative. How far? The height of the wall. Height of the wall is y. It is decreasing. So rate of change, final answer, rate of change of y minus 8 by 3 meter per second. And if you write it rate of decrease of y, then no negative sign, 8 by 3. Rate of decrease means minus dy by dt. So this is the answer. Now sometimes in this problem also it is asked, find the rate of change of slope of the ladder. Now if it is theta, so what is m? M equals to tan theta equals to y by x. So dm by dt, rate of change of slope, this is x square, x into dy dt minus y into dx. So putting value of x, dy dt, y, dx dt, you get rate of change of slope of the ladder. So it is also another part of the problem. Now next problem. Now consider one more problem. So two men M1 and M2 starts with velocities v at the same time from the junction of two roads, inclined at an angle 45 degree to each other. If they travel by different roads, find the rate at which they are separated. Now there are two roads, OA and OB. So they are inclined at an angle 45 degree. So after time t, suppose P is position of the M1 and Q is position of M2. So distance between them is PQ. If they travel by different roads, look, find the rate at which they are separated. So PQ, suppose this one is Y. So you have to find dy by. Since their velocities are same, then OP equals to OQ. Suppose OP is x and this is also x unit. So you have to find relation between x and y. So from cosine rule, you know cos 45. Cos 45 equals to x square plus x square minus y square. So 2 into x into x. So y square equals to, omitting 1 square, 2x square minus 2x square cos 45. So 2x square common, 1 minus 1 by root. So 2x square, 1 minus 1 by root 2. So 2x square, this is root 2. So root 2 minus 1. Root 2 minus 1. And it is finally x square 2 minus root 2. So this is root 2. Root 2 into root 2 is 2. 2 minus 2. So what is y? So 2 minus root 2 into x. We are taking y as positive for practical problem. So this is relation between x and y. Now it is very simple. You have to find rate of change of PQ, that is rate of change of y, because their distance is PQ. So dy by dt, rate of change of y, dy by dt, 2 minus root 2 total root into dx by dt. Now, what is dx by dt? Dx by dt equals to velocity equals to v. It is given. So, root over 2 minus root 2 into v unit time. Now, if two roads are perpendicular, then theta equals to 45 degree. Then you have to use Pythagoras theorem. But here angle is 45. So we are using cosine. So it is also simple problem. Now one more problem. A balloon in the form of right circular cone surmounted by hemisphere having diameter equal to height of the cone is being inflated. That is, look, cone diameter equals to height of the cone in the form of surmounted by hemisphere having diameter equal to height of the cone. Diameter equals to height of the cone. surmounted by a hemisphere, half sphere. So this is the form of balloon, this type. It is inflated, that is, with the help of pumping, it is inflated. So diameter equals to height of the cone. So this is H, this one is H, this one is H. This is O, this is AB, this is C. Now, height equals to H and this is diameter 2H. So diameter equals to height. So this is also 2H. This is also 2H. And this is hemisphere, so half of radius. Now what is total height with respect to total height? So total height of the balloon equals to, this is H equals to H plus 2H, that is 3H. This is total height. Now what is volume? It has two parts. One is conical part and one is hemispherical part. So V equals to 1/3 pi. What is R? H square. R is, and what is height? 2H. 1/3 pi R square. R is H plus 2H. Then 2/3. 4/3 total sphere. This is half of this. 2/3 pi H cube. H cube. Now, what is relation between small h and capital H? Small h is total height of the balloon. So we want to express capital H in terms of small h, because you have to find a rate of change of volume with respect to total height. So what is V? V equals to 1/3 2/3 pi H cube plus 2/3 pi H cube. So 4/3 pi H cube. So 4/3 pi, what is H? Small h by 3 whole cube. So if you simplify it, you will get 4, this is 23 cube, 27, 4/81, 4 pi by 81 H cube. So V equals to 4/81 pi H cube. So you are expressing volume in terms of total height. Now it is very simple, not dV. So dV by dH, rate of change of volume with respect to total height. 4/81 pi 3H square dH dt. So given H equals to 9 unit. H equals to 9 unit. So not dh dt because you are taking derivative with respect to h. So 4 by 81 pi 3h square. So what is dv dh? dv dh. So 4 by 27 pi h square. 4 by 27 pi into 9 square. So 9 into 3. So 4 into pi into 9 and this is 3. So this is 12 pi. So rate of change of volume with respect to height equals to 12 pi unit cube unit per h with respect to height. So unit is not given. So dv dt equals to 12 pi. 12 pi. So 12 pi. So this is cube unit per height. So unit of height. So look it again. A balloon in the form of right circular cone of diameter equal to height. So we are taking diameter at 2h. So height is 2h. Surmounted by a hemisphere. So this is hemisphere. You have to find a rate of change of volume. So it is pumping. So rate of change of volume with respect to height. So that is why we are finding total volume, then expressing volume in terms of total height, then we are performing derivative dv dh, and this is our final answer. So today I have discussed 4 important problems of significance of derivative. More precisely, derivative, these are problem of derivative as a rate of measure. So you practice these problems, they are most important for board as well as competitive exam. Thank you.